I ended the previous lesson with a question. I asked you if the force of friction comes into play only when the two things are in relative motion. Let's discuss this in detail. Let's say you want to move the stationary sofa in your living room and the sofa is really heavy. What happens when you give it an initial push? Yes, you're right. Nothing happens. The sofa doesn't move even though you're applying a lot of force. Why do you think the sofa doesn't move? Well, the answer is static friction. The force that you apply is balanced by a frictional force by the floor. And this force is applied in the direction opposite to your push. This force is nothing but static friction. The concept of static friction is really amazing. Why do I say that? The reason why I say that is because it is a self-adjusting force. As you increase your force of push, the force of static friction increases too, and the forces are still balanced. Now I know what you must be thinking. After a few seconds, the sofa begins to move, right? What happens to the static force then? Let's discuss this with the help of a simple graph. We assume that the force you apply is a horizontal force represented by the x-axis, and the frictional force applied by the floor is represented by the y-axis. Now, as you increase the horizontal force applied, the frictional force is also increasing accordingly to keep the sofa at rest. This continues till a point where the sofa just starts moving. And that's where the static friction ends and the sliding friction begins. The sliding friction is more or less constant if you notice. This part of the graph is static friction. It's when the sofa is not moving in spite of the force you're applying. And this part of the graph is sliding or kinetic friction when the sofa begins to move. The point around which the sofa just begins the movement is called the breakaway point. Is there anything else you noticed in the graph? Why is this line at a lower level than the maximum static frictional force? The reason is simple. If you've ever pushed a sofa or some heavy object on the floor, you would have realized that pushing it is a little easier when it's in motion. Yes, it's because the sliding friction is lesser than the static friction that's offered by the floor. That was the concept of static friction for you. So we've seen three kinds of friction so far: static friction, sliding friction, and rolling friction. Can you place them in the increasing order of force being applied by each? Yes, static friction is more than the sliding friction, which will be more than the rolling friction. In all the examples we've seen so far, we've only considered friction between solid parts: ball on a floor, box on a table, or roller skates on the ground. In all cases, both the objects were solid. Does friction come into play only when solid parts are involved? Is there any other kind of friction we haven't seen yet? Do watch our next video to know more.